Welcome to the project demonstration of anti-collision avoidance system and also speed detection and display on the LCD display. So on the LCD display we are going to display the three parameters. One is the distance of the obstacle with help of this ultrasonic sensor, and from that same sensor we are going to calculate the distance of the opposite vehicle at which speed it is moving. So the speed is displaying on the LCD with like units of centimeters per second, and parallelly we are going to displaying our live vehicle speed that will be based on the motor RPM. So as of now we are using the 30 RPM motor speed, and whenever the obstacle detects, the speed will be slowed down and same will be displayed on the LCD screen, and will change the direction after the speed got slowed down. And whenever the obstacle is very near to that sensor, then automatically will provide the audible alert through this buzzer. So here we have interface the SR04 ultrasonic sensor at B0 B1 and L293D motor driver to control the direction of this vehicle. That is two DC motors attached for the vehicle movements. So that interface to the L293D motor driver, and this was interfaced to C0, C1, C2, C3 pins. And at the same time the buzzer interface to the C5 pin of our microcontroller, and LCD displayed connection at the pin number B2 to pin number B7. So the whole system getting power supply from this 12 volts 2 amp battery pack. In this one we are using 6 4 volt 1 amp batteries. In that 3 4 volt 1 amp batteries are in series. These three are in series, so we'll get 12 volt 1 amp. Same battery pack here, 3 4 volt 1 amp batteries are in series, so we'll get 12 volt 1 amp. These two are in parallel, so we'll get 12 volts 2 amp DC output. So that is input to the L293D motor driver. So on this L293D motor driver we can see one regulator, so which will take 12 volts DC input and provide us the 5 volts DC output. So that 5 volt DC is the operating voltage of our microcontroller, LCD display and sensor along with the buzzer, and 12 volts DC is the operating voltage for the two DC motors we are using for the vehicle movement. And this 12 volts battery is a rechargeable battery. So to recharge that, yes, we need to connect the battery at this slot. Connect this in this manner, and on the power supply to this transformer. So transformer will step down the 230 volts AC to 12 volts of AC, and this regulated power supply board will convert that 12 volts AC to 12 volts DC voltage, which is a charging voltage of our battery. So it will charging the battery based on the timing. So we need to keep the battery charger on at least of 6 hours and 8 hours maximum. So before that, if the battery get full charged, these diodes will block the current flow from the battery to the transformer, as well as from the transformer to the battery when in order to protect the battery from overcharging. So once time completes, you can disconnect this charger and all that. Now when we on this, after welcome message displayed, the system continuously displaying the, so whenever the obstacle is less than the 60 centimeters, it won't move, and if it's above that, start moving. The vehicle speed was 15 centimeters, be nothing but vehicle speed, and opposite vehicle the distance is not varying. See, if I place any object, when the object comes fast, then we can see the 99 centimeters per second, the speed of the vehicle. So when it is less than the 30 centimeters, then automatically the direction of the vehicle will change. You can see that. See, it's moving the right direction, and then it move forward sometime, and again it like the left direction, and it will move forward. Okay. You can see the demonstration on the floor. So if it is less than 50, again stops.